Okay, the last thing I want to do in this lesson is to talk about the power of science. And so let's first talk about what a proportion is. So this is something that you should have learned in your geometry class. And so it starts off with a triangle located inside of a triangle. And you have a little triangle that has a length A and a height B. And that's inside of a big triangle that has a length X and a height Y. And so the proportion is going to be A is to B as X is to Y. And you can see that little formula down there at the bottom represents that proportion. So, big deal. So that's something you learn in geometry. Well, let's see how this can be used to measure the radius of the Earth. So this was done by the ancient Greeks 2,000 years ago. And what they noticed was that on a certain day of the year, light from the sun would go straight down a well in the city of Cyrene. And it would go to the bottom of the well, and you could peer over and you could see the bottom of the well. But on that very same day, light would not go to the bottom of the well in Alexandria. So what's going on? Because if the Earth was flat, then sunlight should go down to the bottom of the well in Cyrene, and it should go to the bottom of the well in Alexandria. Unless, of course, the Earth is curved. And so, to me, that is a scientific achievement in and of itself, being able to prove that the Earth is curved based on the way that the light was going down different wells. But this wasn't good enough for the ancient Greeks. So they wanted to measure the radius of the Earth, and this is how they did it. So at Alexandria, they took a pole and they put it perpendicular to the ground. And then here's the sun over here, and the sun is going to the pole is going to cast a shadow out like this. So let's say that, for example, this is going to be the letter X, and then let's say that this is going to be the letter Y. And notice it makes a triangle. So can you spot the other triangle that is going to involve the radius of the Earth in that picture? And you notice that if you've got the radius of the Earth to the city of Cyrene, and then you've got the radius of the Earth to Alexandria, if you were to measure this distance, and they could, because they could walk that distance between the two cities, so now they know this distance here. So let's say that this is capital R for the radius of the Earth, and then let's just say that this is the letter A, for example. So now we've got our two triangles, and we can now say that Y is to X is going to be equal to R is to A. And so they can measure this, measure that, and then solve it for the letter R, and now they know what the radius of the Earth is. And so when they did this, they got a number that was actually within about 1% of the correct number, which is pretty good. Okay, so let's take a break, and when we come back, we're going to find out how did the ancient Greeks measure the size of the moon.